Now let's look at how these three measures of central tendency, the mean, median, and mode, are related to each other and how it relates to skew. Well, let's start off with the normal bell curve that's symmetrical. This is kind of what we expect whenever we measure something having to do with humans. We expect a normal score. Most scores will be in the middle, but then as we get farther away from that central score, there's fewer and fewer people that have those scores. And so in the symmetrical bell-shaped curve, the mean, median, and mode are all the same. There's one's not higher than the other. However, when the frequency distribution is skewed, the mean, median, and mode separate. When there's negative skew, the mode is still the high spot. That's always the high spot is the mode, and the mean gets pulled way over to the left because it is affected by every single score. The median gets affected less by the extra low scores. When we go over to positive skew, the mean gets pulled way over to the right because it's affected by all these extra positive scores. The mode, of course, is still the high spot, and the median gets pulled over a little bit. So when we understand the skew of a distribution, assuming that it's bell-shaped, because that's what human traits are usually distributed as, we can see how the mean, the median, and the mode will relate to one another. Now, we've been looking at measures of central tendency. Let's talk about the other measure that's necessary to describe a distribution. Now remember, normally we're going to have a bell curve, so the location of the high point is a measure of central tendency, and that we've seen could be the mean, median, or mode. The measures of variability are how wide the curve is. That's the other distinctive feature of any given distribution, where the middle is, and then how wide or narrow it is. And that's basically how spread out the data is. You can think of it as the opposite of consistency. If all the numbers are really close and everybody has the same score, there's little variability, little variation, and a high consistency. So there's three ways of looking at it. There's the range that goes from the high score to the low score. There's the standard deviation. That's how much you would expect it to vary. How often do you expect it to be off? And then there's variance, which is the square of the standard deviation. Let's talk about the range. The range can go from the lowest score through the highest score. Or if we want to calculate just a single number, we can take the highest score and subtract the lowest score from it. For example, the three bears that we've seen, Beep Beep, Oliver, and Ugly. Ugly's the lightest at 50 grams, and Beep Beep's the heaviest at 400 grams, and so we can say the range goes from 50 to 400 grams. Or, if we wanted to calculate a single number for it, we would take 400 minus 50 and say that the range is 350 grams. Now, the limitation of the range is that it's based on only extreme scores. It just matters what the heaviest and the lowest is. It doesn't matter what anybody else is. The range will only be affected by the highest and low score. So the question arises, is there some measure of variability that would take into account every score? For example, the number of frozen burritos eaten by last week by each girl. So the question is, what value would give us a measure of how much the variation is? One idea that we could do is we could subtract the average from each score, and see how far it varies from the mean score, and then take the average. So let's try that. Let's go for x minus the average. So I'm going to write this column title as x minus. Now, how are we going to get x bar? I'm going to go to insert. I'm going to go to symbol. And then in Arial, I'm going to look for combining diacritical marks. And I'm going to choose the combining macron. And that's character code 0304. And the combining macron puts a bar over something. So I press insert and then close. Oops, better get this away. Close. And now I didn't have an X there. Okay, let's try that again. Control Z. Let's do insert symbol. Oh no, wait, I have to put the X first. That's the room. X. Oops, I've got caps lock on. Let's do a little X. Symbol, combining macron, insert, close, and we've got X bar there. Not the most beautiful X bar in the world, but it works. And so now we're going to do Lorraine. That's going to be equal. And then the X score is going to be D4. And we're going to minus the average. Now, the average is down here, D12, but D12 is not going to move position. X goes down one each line, but the average is always going to stay the same. So I'm going to do $D, $12. So it'll always be D12. Press enter, and I will do overwrite all cells, and there we have that. Now let's see what the sum of all these deviations are, so that we can calculate this. Now let's see. We want equals. I'm not sure where that formula came from. We want equals sum of E4 dot dot E8, and then we can take the average and see what we get. Uh-oh, it's 0. The sum of all the deviations is 0. So if we were to divide that by n to average it out, we'd still get 0. And that's how it is with the deviations. If we ever add up all the deviations, we'll always get 0. So we can't do the average of the deviations. It's just not going to work. What can we do? How can we get rid of all, see, the negatives and the positive cancel out? The way that we can do this is by squaring the negatives and the positive, and that way they'd all turn to positive. Now you might be thinking, well, we could take the absolute value, but yeah, we could take the absolute value, but you remember from algebra classes when you had an equation with an absolute value, you always had to break it up into two equations. We don't want to have to break things up into two equations. We're going to keep it as one, so we're going to square this. So let's copy that, control copy, and I'm going to title this one, I'm going to put this in parentheses, control V, shift arrow, and now I'm going to put a subscript for squared, and the way that I do that is I go to font and open up font, choose superscript, do OK, and type 2, and now I have a column labeled x minus x bar squared. And so what we're going to do here is we're going to make this equal E4 squared, E4, and then we use the up arrow, that's the shift 6 key for squaring something. And so -2 becomes 4. We're going to do it to all of the squares there. And now we're going to change the this sum. We don't want it to be the square there. We're going to put this as the sum equals sum of open parentheses F4 dot dot F8, close it, and that's 10. So now we have the sum of the x's. So we can put, let's call it the sum of the squared deviations. So I'm going to, I'll make a title here. So I'm going to insert a symbol, and I'm going to go for Greek and Coptic, Greek, and I'm going to look for the capital sigma. There it is, capital sigma, insert, close, and I'm going to copy all of this from up here to get the sum of the squared deviations, control copy. we'll do that. Space, Control V. And it looks like didn't copy the subs. We lost the superscript. I'm going to go to Home, change the font to superscript. Okay. And there we have that. And that is going to the sum of the squared deviations. And that's going to be, once again, it's going to be the sum of F4 dot dot F8, enter, so that should give us 10. And this is such a common calculation, the sum of the squared deviations. We're going to call that, I'm using the single apostrophe to enter text. We're going to call that the sum of the squares, SS, which equals sum of the squares. You'll see that SS symbol all the time in the textbook because it simplifies us from having to write the sum of the squared deviations out. And we're going to have the average deviation. So let's copy this over here. Control copy, put it down here, Control V. Let's see if it'll keep the, we can't get it to keep the superscript very well. And we want to divide this by n to get the average. And so let's put the 2 in the superscript, highlight the 2, go to Home, go to Font, choose Superscript, press OK, and press Enter, and that will equal, let's make this column a little wider so that it will all fit there. That will equal F10 divided by n, which is D11. And that would give us an average sum of the squared deviation equals 2. And so that would be a measure of the deviations of this sample. Now let's go through this again. Let's go through. Let's go back to Excel here. Shift F5. So a deviation score tells us how far a raw score is from the mean. And so this x minus x bar is this deviation score. So it's the deviation from the mean. Now, we think we could average it, but the sum of all these deviations equals 0. So averaging the deviation scores will always give us a big fat 0. It won't get us any place. The solution is to square the deviations before averaging them, because squared numbers are always positive. And this sum of the squared deviations is called the sum of the squares, or SS. Now, we can give the sum of the squared deviations divided by n gives us the average of squared deviations. Now, unfortunately, when you square those x's and divide them by n's, we get weird units because burritos squared is a unit. I'm not sure what it means, but it gives us some type of a unit. But we don't understand what squared burritos are, so we're going to take the square root. And when we take the square root, we call this the standard deviation of a population if we have data for the whole population. If those were the only 5 girls in the world, that would give us a standard deviation. But actually, we've just got a sample. So in order to estimate sigma for the population, we're going to use a slightly different equation. We're not going to use this n in the denominator. We're going to say, well, we don't have the whole thing, so it'll probably be bigger, so we're going to divide by n minus 1. So the standard deviation for a sample to estimate the standard deviation of the population is this formula of S equals the sum of the squared deviations divided by n minus 1. Or sometimes we take that numerator and replace that by the sum of the squares, and we say that the standard deviation is the square root of the sum of the squares divided by n minus 1. Now, these are kind of complex formulas, and fortunately Excel will do this, but I wanted to show you this so that you'd be able to understand what's happening, and so that standard deviations wouldn't be so mysterious.